Okay, so starting off up top, so these are what is called the difference of squares. How you identify this is if you have x squared minus, and then that next term does not have x on it. Okay, so if you notice all of these, it's x squared minus, and then 64, 81, 9, 32. Okay, as opposed to x squared, there will always be minus, but you don't have that x term after it. Okay, so whenever you do these, you identify them. These are what is called the difference of squares. Difference because it's always subtraction. Squares because you're going to be dealing with perfect squares. So we're going to be taking the square root of them. If you look at all the numbers except number 4, and we'll talk about it, all of them are perfect squares up here. Okay? So how you factor these, one, you always look for greatest common factor. Always look for that first. Number 1 does not have it. So after that, I'm going to take the square root of both terms. What is the square root of 9? 3. What's the square root of x squared? So the square root of 9x squared is 3x. This is going to be the first term in both binomials, both factors. What is the square root of 64? 8. And I need to have a 3x plus 8 and a 3x minus 8, and it's factored. That's it. Pretty simple. That's it. Okay. Like I said, the box method is probably going to be the most complicated, the most drawn out process on this whole homework. Or this whole notes saying homework, I guess. So, number 2, what's the square root of x squared? X. What's the square root of 81? 9. And I have an x plus 9. I have an x minus 9. The order in which you put the plus and minus does not matter. If I had x minus 9 times x plus 9, it would be the same. I want you to attempt number 3. Okay, so looking at this, Cade Starnes, what would the answer be on 3?
4x plus 3, then 4x minus 8.
Good? Okay. Alright, so let's look at 4. What does 4 have that those other 3 did not?
8.
8 is my greatest common factor. So I'm going to pull 8 out as my greatest common factor. Can I factor this anymore?
Yes.
Yes. What do I get from x squared minus 4? X plus 2 and x minus 2. Anytime you still have an exponent, you need to look to see if you can factor it further. Most of the time you can. Sometimes you will not be able to. The most factored out form might have x squared somewhere in there. That's fine. But if you still have an exponent in there, you need to look to see whether or not you can factor it further. Okay. So going to number 1. Alright, 1 and 2, we're going to do box method. Okay, so the first thing I need to do is I'm going to do 6 times negative 40, which is, what is 6 times negative 40? Negative 240. Okay. I need to find the factors of negative 240 that add up to positive 1. Alright, and I'm going to show you kind of a little trick to do this, because the list of factors of negative 240 is going to be an extremely long list. But if you're not good at this part of the box method, this little trick might help you out. Or even if you are good at finding those factors, if you have a large number like this, I would recommend doing it this way. This is how I would do this one. Alright, in y equals, I want you to put negative 240 divided by x and go to the table. 1. Okay, so if you do that, you find, okay, negative 15 plus 16, that gives you 1. So negative 15 and 16, those are the factors that we need. So we'll go ahead and just do the box method on this. What goes in the top left box? What goes in the bottom right? Does it matter which boxes I put 15 and 16 in? No. And then now I'm just going to find the greatest common factors. The largest number I can divide 6 and 16 by is 2. 15 and 40 is 5. And because that 15x is negative, that needs to be 2x minus 5. Between 6 and 15 is 3x. Between 16 and 40 is 8. And because that 16x is positive, it is going to be 3x plus 8. So I have 2x minus 5 times 3x plus 8. Okay, so again, the factors of negative 84. The factors of negative 84 that equal 8 are 14 and negative 6. So I'm going to have 4x squared in the top left, negative 21 in the bottom right, negative 6x and 14x. And then I'll find the greatest common factors going through that. So I've got up top, I would have 2x, and I would have 3 because that negative 6x is, or that 6x is negative, it will be 2x minus 3. And then I would have 2x plus 7 on the left. Okay, so let's talk about, so this next one's going to be a new method that we have not talked about. What is different about really the rest of the problems compared to the ones we've seen? Do what? There's more terms. Okay, so we're going to factor these by a method called grouping. Okay, again, it is not as lengthy as doing the box method, but you identify it as there's 4 terms. Okay, so the first thing I'm going to do is I'm going to take the first 2 terms and I'm going to group them together, and then I'm going to take the last 2 terms and I'm going to group them together. Then within each group, I'm going to find the greatest common factor. So looking at in the first parentheses, what is the greatest common factor between 3 and 6? Between x squared and x? Okay, so that's going to leave me with x minus 2 inside the parentheses. Whenever I take the factor out of the second set of parentheses, I'm trying to make sure that that comes out to x minus 2 as well. Those two need to be the same. What is the greatest common factor in that second set of parentheses? Positive 4. Once you have that, the factor that is repeating itself, that's one of the factors in your answer. This next part is the part that some people have kind of struggled wrapping their mind around. you take those two, the two factors that you pulled out, and you put them together to make another factor in your answer. Okay. Let's look down at 5 real quick. So it's already set up as grouping. It's already pulled out the greatest common factors. The x minus 5 has repeated itself, so that's going to be one of our factors. What would the other factor be? 4x minus 1. You need to make sure that you see that subtraction. That's going to be a minus 1 in there. Okay, so on that one, on number 4. So again, you put the first two and the last two together. Now what makes this one a little bit different than number 3 is that third term is negative 3x. Okay, it is a negative. So in the first set of parentheses, I pull the x out. And I'm left with x plus 6. So that means I'm trying to make this x plus 6 as well. To do that, I need to pull out a negative 3, okay, not just a 3. Because that negative 18 divided by 3 would have left me with minus 6, and I want it to be positive 6. And then once I have that, I got x minus 3, x plus 6. We'll quickly look at 7. We're going to skip 6. We'll look at 7 and 8. We'll do these together though. So I've got the 4 terms, so I'm going to look to do grouping. What's the greatest common factor between 10 and 6? 2. And then x cubed. 10 divided by 2 is 5. There were 4 x's there. I took 3 away, so there's just 1 left. 6 divided by 2 is 3. There were 3 x's. I took all of them away. In the second set, what is my greatest common factor? One what, Jonah? 1x. Or just x. Remember, let the fact that I want this to be the same as this kind of help you figure out what you need to pull out of there. So next I've got 2x cubed plus x times 5x plus 3. Can I factor it anymore? What can I do to that first set of parentheses? No, there aren't like terms in there. Can I pull anything out? I can pull an x off of both terms. And I can't factor this anymore. Let's look at 8. So it's already set up. For grouping. And we're going to talk about, we're actually going to talk about that situation, that first binomial. What this one would end up turning into is going to be something like this. Okay. Just that first 8x cubed minus 27 turns into those two right there. And then you would still have 3x minus 1. which that is what we're going to talk about on the next page. But before we do that, let's put the steps of grouping. So step 1, pull out the GCF if possible. Two, group the first two terms and the second two terms together. Three, factor out the GCF from each group. And then the terms on the outside become one factor. And inside becomes one factor. So let's look at, I'm just going to do this top page, or top half. So you need to be able to identify these. These are what we call sum and difference of cubes. Okay, so these are going to be the ones where you've got a cubed, okay, x is being cubed, and plus or minus a number. The only time when that might be a little bit different, and we won't see it a lot, is whenever you have another variable in there. We won't see that very often. Okay. So whenever you have x cubed plus or minus a number, you're going to look to do this. Now this has a nice little acronym to tell you what the sign should be in your final answer, because the world doesn't have enough acronyms, so we're going to have one more. It is just that SOAP, which stands for same sign, opposite sign, always positive. So if you look up in the examples, up at the very top, that is an a cubed minus b cubed. So since that is a subtraction problem, the signs in your final answer, they're going to be the same, opposite, always positive. If it is a plus, it's going to be same, opposite, always positive. Okay? Do what? Is that better? Alright. So, next, just like whenever we had the difference of squares, we took the square root of stuff. On this, we're going to have to take the cube root of something. Does anybody not know how to take the cube root in the calculator? Raise your hand. It is probably a significant amount of you. The way AJ is looking around to see if anyone else is raising their hand tells me she does not know how to do it. So, if you look on the left column of your calculator, the math button, hit math, go down to number 4, and on this first problem we're going to have to find the cube root of 27. So go ahead and do that. Cube root of 27. 3. Alright, so let's look down at number 1 and how we're going to approach these. Just because of the way it's set up and the way the basic formula is set up, you're going to identify A and B. A is going to be the cube root of the first term. B is the cube root of the second term. So A is the cube root of the first term. B is the cube root of the second term. On these problems, there will always only be two terms. So the cube root of 27 we said was 3. What is the cube root of x cubed? What's the square root of x squared? X. So what is the cube root of x cubed? What is the cube root of x cubed?
X.
X. Thank you. So, since this is a subtraction problem, usually I will go in and I'll go ahead and put my signs in. So it's going to be same. I'll have a binomial first, and then I'm going to have a trinomial. So same, opposite, always positive. And if you look up top, that's what you're going to do to each one of those terms. Your binomial is just going to be the A and the B term. So on this problem, we're going to have x minus 3. For the trinomial, you're going to have A squared, which on this one is x squared. Then you're going to have A times B, which is 3x. And then you're going to have B squared, which is 9. And that's factored. That's one of those problems factored out. Alright, let's go down to 4. We'll do 4 together because it's kind of the oddball. So what is the cube root of 125?
5.
What is the cube root of x cubed? X. So the cube root of 125x cubed is 5x. Do not complicate it just because it has a coefficient in front of the variable. So what would the cube root of 27y cubed be? 3y. I'll go through and put my signs in. So I'm going to have same, which is plus because there's a plus in the problem. Opposite, always positive. So first is just A and B, so 5x, 3y. What's the first term of my trinomial going to be? Nope. If your A term is 5x, you have to square the 5 as well as the x. So 25x squared. Okay, because you're not doing this, you're doing this. 5x times 5x, which is 25x squared.
But then why would you keep the square when you put it in?
Because it's still on the squared.
Okay.
Or sorry, it's still on the x. So now you have A times B, which 3 times 5 is 15. Do not complicate x times y, it's just xy. So what would the last term of this be? 9y squared.